Hello everyone. Before we go ahead and implement the next set of items, let's have a quick recap of what are the things that we have seen so far. So we have loaded our data set, which is Wikipedia data set from Hugging Face. We randomly selected a couple of articles from this data set. We did basic pre-processing techniques like removing stop words, punctuations, numbers which are present in the article. And then we use the technique called TF-IDF to convert these string inputs into vectors. And we also performed a technique called keyword extraction where we extracted top K keywords from the articles. In this video, we are going to perform clustering and see how well these articles are divided into different subgroups. Let's get started. Before we go ahead and implement KMeans, let's have a quick recap of what are the code that we have done so far. So we have loaded our data set, which is Wikipedia data set, using Hugging Face data sets. Since the data set is really huge, we are collecting 500,000 articles. So we are creating random samples of 500,000 index and selecting 500k articles from the entire data set. Since we are interested only on the text part, we are taking only the text part of those articles, and we have converted this particular articles into a data frame. Now for performing clustering, we have selected 3 different categories. So the first category is sports, and we have taken 3 keywords like player, team and score, and we are going to select the articles which contains any of these keywords like player, team or score, and we are going to shuffle it. And for each category, say for sports, we are going to take 1000 articles, and here we can see a sample article and it's mapped to the category. And similarly, we are going to select another category where we are going to have keywords like theorem, proof, equation and formula. So these articles would be related to mathematics, and again we have collected 1000 articles. And we have one more where we have river, lake and ocean, and these are categorized into geography. And I'm concatenating all 3 different data frames, sports, mathematics and geography together, and we have an data frame with 3000 articles. Now we are going to convert this into list because we have to pre-process it and vectorize it. And here I have downloaded all the stop words, and yeah, let's save the stop words in a variable and perform basic pre-processing such as removing punctuations and selecting removing the stop words and numbers, and converting this article into lowercase. So once all these things are done, we go ahead and vectorize it. So here we have we are using TF-IDF vectorizer, and here is the vectorized output where we have 3000 articles and 23,346 features. Now we can use this TF-IDF vector and we can implement KMeans. Let's imagine we have a couple of articles related to sports. Let's say S1, S2 and S3, right? And a couple of articles related to geography, G1, G2, G3, right? And let's say we have articles related to mathematics, M1, M2 and M3. Okay, so what KMeans does is basically it computes the centroids. So first it randomly initializes number of centroids. Let's imagine we have to cluster this articles into 3 different subgroups. Okay, so what it basically does is it assigns random centroids. So for example, C1 here, let's have C2 here, and let's have say C3 here. Okay, So once it assigns random centroids, it computes the distance between each centroid and the articles. Okay, so what happens is it computes the distance between C1 and this particular article, C1 and this particular article, C1 and this article, and so on and so forth. Okay, so the distance between the centroid and the article is the Euclidean distance. Okay, so whichever article has the lesser distance, that particular article gets assigned to that particular centroid. So for example, if you take the distance between S2 and C1 and S2 and C2, S2 and C1 is less, so the article S2 gets assigned to the cluster number 1, right? Similarly, S1 gets assigned to cluster number 1, but here we can see that the distance between article centroid C2 and the article S3 is lesser. So this particular article S3 gets assigned to C2. Now the sports article 1 and 2 are in centroid 1, which is in the first cluster, and other articles we are going to have it in cluster 2, right, because these are much nearer. And similarly C3, so all these articles would belong to C3, right, C3, right. So this is nothing but our iteration 1. Okay, so on the first iteration we find the distance between the centroid and all the articles, and whichever article is nearer to the centroid, that particular article gets assigned to the cluster, right. So once this particular iteration is done, for the next iteration there is one more process. Okay, so before we go to the next iteration, once again the distance between the centroid and the articles are calculated. Okay, now for centroid C1, what is the distance between C1 and S1, C1 and S2, C1 and S3, and so on and so forth, right? It sums up all the distance, say 12, 14, 16, okay, and so on and so forth, right? And it computes the average of all this distance. Okay, so for example, average is 14.5. Okay, and what it does is basically it moves the centroid point from here to the average point. So our centroid point now will move from C1 to C1 moves from here to say here. Okay, and similarly let's move our C2 to here. Instead of here, it moves here. Let's say C3 moves from here to here, right? Now after computing the centroid points, the second iteration will start. Okay, so we are going to have the second iteration, right? Here let's go and have the second iteration 2, right? In iteration 2, similar to iteration 1, we are going to compute the distance between the centroid and the articles and see which particular article is much nearer to the centroid. Now let's do it again, right? Now we can see the article S1 is nearer to C1, S2 is nearer to C2. Now the article S3 is much nearer to C1 than C2, right? S3 is nearer to C1, right? So now the article S3 belongs to the cluster 1. Okay, and once again we are going to have G1, we are going to have G2, we are going to have G3, right? And we can see similarly we can do for M1, M2 and M3, right? At the end of iteration 2, we can see that the article S3 now belongs to first cluster, right? So this particular process is done multiple times. Okay, so for example, when you reach iteration number 20 or 21 or 50, at some point of time the centroid will be keep on moving based on the average distance, and some point of time when it reaches a convergence condition, the movement of centroid will be stopped, right? The centroid doesn't move much, and we can clearly see that the centroid sticks to one particular place, and that is the convergence condition, right? So once the convergence happens, it clearly has the decision boundary now, right? So this is our cluster number 1, this is our cluster number 2, and this is our cluster number 3, right? So all these articles are tagged to C1, and all these articles are tagged to C2, and these articles are tagged to C3. Implementing K-means is a pretty straightforward process. Let's use sklearn. So from sklearn.cluster import K-means, and our K-means package will be K-means object will be K-means is equals K-means of, we have to specify the number of clusters that we want. Let's start with 3, and there's a parameter n in it which we are going to set it to auto. So basically this n in it is how many times the K-means has to run and fetches the best result. So let's set it to auto, and our outcome would be K-means dot fit and predict. We are going to both fit and fit the articles and predict the outcome. Our x will be the TF-ID vector, right? So let's go ahead and print the length of labels. So now we have all 3000 variables, articles predicted, and each article is associated with a cluster number. So let's print the labels and see. Here we go, right? So we have different numbers 2, 1 and 0. Okay, with the predicted labels from K-means, it's very difficult to understand how these articles are grouped into different clusters. To solve this, we are going to add a little bit of visualization. To visualize these articles on the cluster space, we are going to extract top 10 words from each cluster and plot it. To do that, let's first derive all the words. So feature names will be vectorizer dot get feature names out. Now the feature name contains the words which are there in our vocabulary, and for instance, if I add a random index 1 2 3 4, we can see that word arises is mapped to this particular index, right? So when we implemented our K-means, we had defined the number of clusters to 3, right? So we'll have 3 centroids. Okay, let's go ahead and get the centroids. Our centroids will be K-means dot cluster centers. Okay, so let's print the length of centroids. It should be 3, right? Now it's 3. So let's loop through each centroid for I comma centroid in enumerate of centroids okay. For each centroid, for now I'm going to print the centroid and add a break statement here. Let me print the shape. Now we can see this is the first centroid, and this centroid contains 23,346 words. Okay, so let's go ahead and sort these based on their importance. To do that, sorted indices equals, let's do centroid dot arg sort. So this will sort, but I want to sort it in a descending fashion. Okay, now let me print the same sorted indices for the first centroid. Here we have the break statement, so it prints only for the first centroid, right? So now we have all the sorted indices, right? So let's go ahead, now we have all the numbers, so let's go ahead and get all the words. To do that, as we know, we have more than 23,000 words here, right? So let's first have a variable top n, which is 10. Now I'm going to get only top 10 words from this, right? So I'm going to loop through this for IDX in sorted indices. I'm not going to loop through the entire array. I'm just going to loop through till top 10, right? And my index is nothing but 8023, right? So the word will be feature names of IDX, right? Now let's print the IDX and also the word, right? You can see 8023 is mapped to film, 795 is mapped to American, and so and so, right? And we can also get the score. To get the score, feature names of centroid of IDX. We just pass this IDX and get the score. Now we also have the score with us, right? So this is for the first centroid, right? So similarly we have to fetch it for all the centroids. So let's go ahead and create a dictionary. So I'm going to create a dictionary to save this output, right? So and initialize this dictionary with empty initially, and whenever I find a score, I'm going to update this dictionary with a score. So of I of word will be my score, right? So what happens here is, let me print the cluster word score so that we know what happens. Let me print inside the for loop. Now we can see whenever it finds a word and its score, it gets appended into a dictionary, right? Now let me remove this print statement. Let's remove this break statement. Run this. For all three centroids that we have, we are going to compute top n, which is 10 words which are most important, and store in this particular dictionary. Now let's print this dictionary. We can see we have three centroids, 0, 1, 2, and for each centroid we have the word and its importance, right? So we have for each centroid we have the word and its corresponding importance, right? So let's go ahead and plot this. To do that, we are going to use the library word cloud. If you don't have this library, install it using pip install -u word cloud, right? So let's go ahead and import the word cloud. From word cloud, import the class word cloud, and I'm also going to use matplotlib. So the pyplot as plt. Okay, so let's go ahead and write a method to plot for each centroid that we have. We are going to plot this word cloud. So let's write it as a method. So define plot word cloud, right? We need the cluster number and we need the word scores, right? So once we get it, let's create a word cloud, which is our word cloud of, let's set the background to word cloud. Let's set the background color to white, right? And let's generate this word cloud from the word scores that we have. So this word score is nothing but the word and its corresponding importance. Okay, and let's plot it. Plot dot figure. Let's set the figure size. So that will be, our fig size will be 8,2, right? Okay, and let's do the IM show of this word cloud, right? And let's also set the interpolation to bilinear. Okay, now what we can do is we can loop through the cluster index, okay, and the word scores for cluster index and word score in the results that we saved, which is a dictionary dot items, right? So here we have the cluster index and we have the word score. Let's go ahead and plot it. So plot word count of, let's pass the cluster IDX and the word score, right? So let's run this. Plot is not defined. Oh, this is plt.im show. Yeah. Let's run this now. Should work. Yeah. So we can see we had 3 different clusters. Here we have set our number of clusters to 3, and we have 3 word clouds with us, right? So let's remove this access, plt dot access of. Now we can see it will generate without the access, right? And we also need to know which cluster it belongs to. So let's add a title of F. So we have the cluster ID, which is cluster number. So when it's 0, I want to give it to 1, right? So let's have this plt.show, right? Okay, so now let's have cluster, right? Again. Okay, now we have 3 different clusters, right? For each cluster we have 10 words, and we can see these 10 words are like almost in this particular word cloud we have articles related to films, American universities and stuffs. And here we can see the clusters where in the second cluster we have things related to sports, where we have words like players, championship, football and seasons. And the third cluster, again we can see that we have the words related to geography, which is county, lake, river, district, right? So overall looks like these clusters are well separated. We can play around with different numbers, like for example we can increase this number of clusters to 4, right, or even 5, right? Let's run the prediction again. It generates output for all 3000 labels. Let's go ahead and do the same process, extract, even we can extract top 15 words, right? And once we have all the words, let's plot it. So let's plot it now. So now it's going to plot for 5 different clusters. So we can see here we have rivers, county, area, lake, right? And here it's pretty much about the sports and so on and so forth, right? Here we have related to films, right? So as we can see, we can perform basically identifying the number of clusters is kind of a very tricky problem here, because the clusters are formed based on the words that we have it in the articles, right? We cannot we cannot set the number to 3 and expect the results to be having sports, geography and mathematics, because K-means basically clusters based on its word frequencies and other stuffs, right? So to identify different set of subgroups, we need to play around with the hyperparameters such as number of clusters and and other hyperparameters, and see which cluster is giving us a logical result. And by looking at this word cloud, so when we had number of clusters as 3, we can clearly see, right? So each cluster is separated with geography, movie and and the sports, right? So what we can do is, like, we can go through these clusters and we can update the indices, clusters indices, as maybe 1 is sports, 2 is movies, and 0 is geography, right? In that way we can segment our original articles into different groups. The K-means algorithm has its own pros and cons. K-means is much easier to implement and it can perform the training as unsupervised. It's much faster as it converges very quickly, and we don't need GPUs for running K-means, right? But at the same time there are other cons as well. For example, finding the number of clusters is very tricky. For example, when we are using more than 6 million documents and we have to cluster a huge amount of billions and billions of words, it's very tough to do it with K-means. And even if we find out the number of clusters and cluster them into different groups, we have to employ someone to go through the output and find out the topics of each particular cluster. If the content was helpful, please hit the like button and subscribe to the channel. Thank you.